Now let's look at tables. You can model exponential functions with tables and graphs. So with tables here, what you're looking for is you're trying to see, can we figure out the pattern for the numbers, right? Is it being multiplied or divided by a certain number? So one thing that I do is I say, if, of course, we could determine if it's growth or not just by simply looking at the increase, since that's going to be going up. It would be a growth model. If it would be starting high and going down, it would be decay. So in this case, it's going to be growth. A decay might look like, let's say, 2, 20, 3, 10, 4, 5, and you can see it's being divided by 2. That's an exponential decay. So when it's 1/2 is being cut in half each time. So what is the pattern here? How much is it growing? Well, what I do is I take one of the amounts here. So I would take like 768 and I would simply divide by the 192 just to see what I get. So take this number, divide by this number, and then you'll see what that number is. If I were to take 192 and multiply it by that number, it'll get me back to 768. So you can use your calculator to do that. You can do 768 divided by 192. And you can see that's going to be 4. So that means 192 times 4 is going to get me back to 768. So then take your 192 just to make sure and divide that by 48. Then you're going to get 4 as well. So now we figured out our constant multiple. That constant multiple, that's your base, right? It's times 4 to get to the next number, times 4 to get to the next number. Your base value is 4. So then you get this equation that's going to look like this. Y equals a times 4 to the x power. We don't know what a is, but we do know that that's your starting amount would be when x equals 0, which our table doesn't start with. It starts at 2. So we have to work backwards to get to what a is. So I know that a can be gotten by just basically dividing by 4, right? If I divide 48 by 4, I can continue that trend. So when x is 1, 48 divided by 4 is 12. And so I need to go 1 up. When x is 0, 12 divided by 4 is 3. So I know that my starting amount, that 3 is going to be my a value. So now I have the entire function. I have the function modeled as an equation. So I can keep working backwards. I can put that 3 in the place of a, and I can graph it now. So you can see, let me graph this here. Y equals 3, parentheses 4 to the x power. And I'll press the home screen to get that where it should look like. And you can see it crosses at 3. It's an exponential growth because of that 4 inside the base, because it's being multiplied by 4. And if we wanted to, we could figure out some additional numbers. Like I could figure out what's the value at 1, or 2, excuse me, would be 48, which is what our table had started with. And you could keep going to 3, 192, 4, 768. So that's your function. Then you could go beyond that, and you could say, all right, what is f of 5? What is f of 6, 7, 8? Doesn't matter. You could just keep that table going. So if you know the pattern now, it's times 4, times 4. Then you just take that 768 and you times it by 4. And you take that number and you times it by 4, and then you'll figure out what f of 6 is. So we can do that in our calculator again. That's not something I am able to do quickly in my head. So 768 times 4, 3072, and then 3072 times 4 is 12288. 3072, 12288. So f of 6 is 12288. But you know, there is an easier way to do that. Because I had written my function out, I can plug 6 into the exponent. So 3 times 4 raised to the 6th power. And that's going to look like the same number without all that extra work. 3 parentheses 4, shift 6 raised to the 6th power, and there's your 12288, 12288. So just to kind of recap, you could keep multiplying by 4, or you could plug in 6 to get your answer.